Money is almost always central to running a project. It is usually the case that money is the primary constraint. Stakeholders seem to be more concerned about cost than nearly anything else. The old saying is quite true: money makes the world go round, and your project run. You cannot develop a reasonable project budget until you know what you are building, the materials that go into it, who will be working on it, what they cost, and where the money will come from to pay for it. Therefore, there is a lot of work to get done before being able to start estimating what it will cost. However, if you wait too long, your stakeholders will lose confidence in your capabilities, the project's viability, or both. Hence, cost planning has to happen early and is usually done in progressive steps of refining the cost within tighter ranges of confidence. The problem is that your knowledge about the project is very low when the project starts. The number of unknowns, or project uncertainty, is super high at the beginning. Uncertainty decreases only after you start defining scope, identifying resources, and understanding activities and their durations. Unfortunately, your stakeholders want to know the cost as early as possible. Because of this uncertainty, project and product scope changes. It should be no surprise to hear that cost and scope are tightly linked. Increase the scope and you almost certainly increase the cost. It is also understandable that the best time for a project team or stakeholders to influence the project scope and therefore cost is early on, for example during early planning and design. You can see this nicely here in this graphic, the ability to affect scope curve. The team's ability to affect project and product scope decreases over time. This is because expectations are set and some key decisions have already been made that anchor the project path. For instance, changing the number of engines in a new airplane design, or the number of floors in a house, or switching from buying software to developing it yourself. Those big decisions should be made early on in the project. Those are so big that it is difficult to change them even within just a few weeks of the project starting. This is true even for adaptive projects, ones that allow for change. Although they are designed to handle most changes better than predictive methodologies, some changes to base components in the project become more difficult to change the longer the project has been running. There is one more major factor: cost of change. The cost of doing a change increases rapidly as your project progresses. This cost of change curve here shows you the relative cost in the early stages of the project and how the same change would cost more later on in the project. Think about it. Planning to make a house, a two-story house, isn't cheap, but if you wait until the roof has been put on it to finally say, oh, you know what, we need another story on top of that, it's far more expensive. You would have to remove all or part of the roof, build another story on top of it, and then replace the roof again. In fact, your foundation may not even be designed to handle the extra weight. Again, this is true even for adaptive projects, those that allow for change. Although the costs for change may be lower than in predictive, a change later on in the project generally costs more. The answer is obvious. The earlier you make such scope-related design changes and decisions, the less expensive the project will be. Procrastination causes cost to skyrocket. After this review of the key aspects, we will proceed to look more closely at the 7 processes that make up project integration management. In the individual lessons of the appropriate process, we will discuss each of them in detail. Right now, our goal is to provide you with a high-level understanding. The first process is develop project charter. This is the process of developing a document that formally authorizes the existence of a project and provides the project manager with the authority to apply organizational resources to project activities. The second process is develop project management plan. That's the process of defining, preparing, and coordinating all plan components and consolidating them into an integrated project management plan. That's followed by the direct and manage project work process, the process of leading and performing the work defined in the project management plan and implementing approved changes to achieve the project's objectives. The next process is manage project knowledge. That's the process of using existing knowledge and creating new knowledge to achieve the project's objectives and contribute to organizational learning. The fifth process is monitor and control project work. The process of tracking, reviewing, and reporting overall progress to meet the performance objectives defined by the project management plan. Then we have perform integrated change control. This is the process of reviewing all change requests, approving changes, and managing changes to deliverables, organizational process assets, project documents, and the project management plan, and communicating the decision. And then finally, we have close project or phase. Its purpose is to finalize all activities for the project, phase, or contract. And here is how the 7 processes from this knowledge area map to the various process groups. Develop project charter is part of the initiating process group. Develop project management plan is in planning. Well, no real surprise here. The plan is in planning. Well, that makes sense. Next, we have direct and manage project work as well as manage project knowledge. Both processes are part of executing. They are in this process group because for once you are not just doing project management work, but you are actually doing some real work on the project deliverables. It should also come as no shock that both monitor and control project work as well as perform integrated change control are part of the monitoring and controlling process group. And lastly, as you would expect, close project or phase is part of the closing process group. And here is one last piece of trivia. Close project or phase is the only closing process anywhere in the PMP guide. No other process falls under closing. You can see that project integration management is unique. It has 7 processes, at least one is found in each of the 5 process groups. That makes integration management the only knowledge area that has one process in each of the 5 process groups. Think of these 7 processes as the lead chair in the sections in the orchestra, each playing their parts at just the right time as conducted by you, the conductor, the project manager. For instance, the second process in integration is develop project management plan. This particular process is leading the planning process section of the orchestra. Moreover, the responsibility of the process is to ensure that all the other 23 processes, in our analogy, all the woodwinds in this planning process group are properly coordinated and executed. Also, what you see here is probably the most colorful slide that we have anywhere in the Prepcast. It looks like we have managed to squeeze every single color that we use for highlighting onto one single screen. In this lesson, we focus on Enterprise Environmental Factors, or EEFs for short. Specifically, we provide an overview of what they are. This includes a comparison between EEFs and the Organizational Process Assets, the OPAs. We discuss two types of EEFs, namely internal and external factors. We then describe how EEFs are used as inputs and outputs, and finally we identify several examples for each process group. The influence of EEFs on different project management processes is quite vast. This lesson aims to provide you with the foundational knowledge of these EEFs so that you can build on it when you encounter EEFs again in future lessons as well as on your projects. EEFs are mentioned throughout the PMP guide, but for this lesson we focus on the material on pages 38 and 39. Grab your guide and open up those pages if you want to follow along. We begin with a hypothetical situation. Imagine you have just been informed that your next work assignment is to manage a project in a different country. I bet you'd want to find out more than what's just in the latest weather report. Apart from figuring out what to pack in your luggage, more importantly, you need to know what to expect and how to best manage this new project. You would want to get familiar with the culture, its geography, the political situation, the security, the infrastructure, and so on. These are but a few examples of what are called Enterprise Environmental Factors, or EEFs. By the way, these EEFs can affect any project, not just international ones. With this in mind, it's time to look up the official definition of Enterprise Environmental Factors. The PMP guide formally describes EEFs as conditions not under the immediate control of the team that influence, constrain, or direct the project, program, or portfolio. When we break down this definition, it's very important to note that EEFs refer to conditions that are not under the immediate control of the team. Remember, this is your outside environment. Neither you nor the project team can readily change these factors or conditions. If you think about it, there are many environmental factors that surround a project and influence its success. You should think of the dynamics which not only influence, constrain, or direct your project, but which in general your project team cannot control. Closely related to EEFs are the Organizational Process Assets, or OPAs. Coming from the definition, we know that EEFs are about the conditions or the state of the project environment, as opposed to OPAs, which are all about assets, often documents or knowledge bases. EEFs can be both internal or external, whereas OPAs are internal to the organization only. EEFs and OPAs are both very common inputs to the project management processes. However, there are only very few processes with EEF updates when compared with OPAs, which are frequently updated because our project changes them. EEFs are not under the immediate control of the project team. As this is about the environment, there is very little that the project team can do to influence it. Both EEFs and OPAs can and do influence our projects in many ways. But first, let us see where we are in the overall PMP guide map. We are in Project Resource Management and, as the process name implies, in the Planning Process Group. And we are at the second process, Estimate Activity Resources, which is defined as the process of estimating team resources and the type and quantities of material, equipment and supplies necessary to perform project work. If you would like to follow along in your own PMP guide, please turn to pages 320 to 327. A central theme in estimate activity resources is that you should have a thorough understanding of the resources required for each individual activity in order to achieve an accurate estimate of duration and costs for the project as a whole. In other words, if you understand the resource details at the activity level, then figuring out the total cost and duration will be a breeze. But if you fail to understand the required resources, then you can expect cost overruns, schedule slippage, and possibly total project failure. The Estimate Activity Resources process helps us to identify and quantify the resources required for each activity. For any given activity on our project, we may require some or all of these resources here: people, equipment, material, as well as goods or supplies. So even though we focus mainly on the topic of estimating what type of human resources are needed to perform our activities, we should never forget that our activities may also need some or all of the other types. Furthermore, when you estimate resources, you should also consider these 4 factors here, starting with the complexity of the task, then the skill level that is required of the resource, the organization's history in doing similar activities, and finally, the required resources availability. If you properly weigh these factors, you should be able to provide accurate estimates for the resources required. Next, we have the 3 common estimating techniques that you have already seen in both cost management as well as schedule management lessons. Bottom-up estimating is often on the PMP exams. It's a PMP exam favorite because even though it is time-consuming, it is the most accurate of estimating approaches. Some call it the engineering or grassroots estimate because of the level of detail involved. The key is in the detail. When you break down an enormous task into smaller, more manageable tasks, then the task becomes small enough to make a considered estimate for the required resources. After you assign people, equipment, material, and supplies, you get a total for that single task. Add up all these estimates, and that is bottom-up estimating. When each and every task on the WBS has its own detailed estimates, the number can be aggregated at a different level or totaled for the entire project. Analogous estimating is certainly quicker and easier. This method uses the common features of similar past projects based on recent historical data. And then parametric estimates are simple math tools. They are algorithm-based. If you have current up-to-date data, you can use a formula to make an estimate based on proven relationships. For example, a paving company knows its past cost per lane mile paved and even the cost of a mile of painted centerline. Very handy, but using this tool requires current, accurate, and relevant data. Here is our usual process groups and knowledge area mapping. We are in project risk management, and as the process name implies, we are in the planning process group for this knowledge area. And obviously, plan risk management, the process here is defined as the process of defining how to conduct risk management activities for a project. If you would like to follow along, please turn to pages 401 and to 408 in the PMBOK guide. The main concept that you should remember is that in this process we are not interested in planning how you manage the actual individual risks. Instead, we are interested in planning how to approach and execute the risk management activities on your project. For instance, how will we identify our risks? How will we define probability and impact of risks that we have identified? What techniques will we employ to define risk response strategies, and how will we monitor our risks during the life of our project? In other words, we want to create the risk management plan. What are some of the benefits of risk planning? Well, by planning your risk management approach early in the project lifecycle, you ensure that risk management receives the appropriate visibility to the stakeholders and corresponds with the size and strategic importance of your project. You would very likely plan for high visibility of risk in a large strategic project. On the other hand, you would aim for low visibility on a project that is the fourth in a series of 6 similar small projects. This ensures the risk management plan activities receive the attention that is proportional to the project's importance to the company. Again, remember, risk planning needs to start early on in the project and may need to be revisited if there is any significant scope change. Let us dive into the inputs of this process. And they are the project charter, the project management plan, and interestingly enough, for planned risk management, we use all components of the plan as inputs. Whereas from the project documents, the stakeholder register is most important. Then we also use the enterprise environmental factors and some organizational process assets. Let's look at why these are significant in helping us create our risk management plan. First, we have the project charter as an input, which supplies the following high-level information. The initial high-level risks that are identified on the project. The project description that helps us identify risks based on what is and what is not included in the project. Requirements that can shed light on how much risk is inherent in our project. For example, many complex requirements means high risk, while simple requirements usually imply less risk. And then assumptions and constraints both directly relate to the level and type of risk in a project. What do you think happens when one of our assumptions proves invalid later on? Well, risk increases. Next, we have the information contained in the project management plan, which influences the planned risk management process. In preparing the risk management plan, all management plans and baselines must be considered for the risk management plan to be consistent with them. So let's review then some of the reasons why these subsidiary components within the project management plan are important. First, the more complex our cost management plan is, the more inherent risk there is on something going wrong in managing our cost. We would want to know the aggressiveness of schedule objectives within the schedule management plan as an indication of the risk of meeting those objectives, and the communications management plan can help us answer questions on how many and with whom we have to communicate. And since one of the biggest problems on many projects is poor communication, there is a strong connection between planning communication and decreasing risk. Also, all baselines, such as the scope, schedule, and cost baseline, should be taken into consideration. The methodology outlined in each of these plans is essential, since these are all risk-affected areas. Next, we have the project documents, and an important one among these project documents is the stakeholder register. The lessons about project communication and stakeholder management explain how the stakeholder register contains details about the project's stakeholders. So why is the stakeholder register important to risk management planning? Well, this document informs the project manager based on power, role, and level of interest which stakeholders are likely to impact the project. Stakeholders with high potential impact likely need and expect to be involved in the planning of risk management activities. Since they typically can provide or limit resources, their ability to influence risk is substantial.
Secondly, the stakeholder register contains the classification of the project stakeholders. Are they supporters, resistors, or champions? Risk planning includes information about who may cause risks, like a resistor, and who can reduce risks, like a champion. In essence, this information helps the project manager to associate a level of risk to a stakeholder. The better the project manager knows their stakeholders and level of influence, the more effective and purposeful risk planning is. It is also useful in determining roles and responsibilities for managing the risk on the project, as well as setting the risk threshold for the project. The relevant information from the enterprise environmental factors that we want as an input here are the risk attitudes of both the stakeholders as well as the sponsoring organization. There are three themes that influence these risk attitudes. First, how much uncertainty will an organization take in anticipating a reward from a project? In other words, what is their risk appetite? Second, what is the measurable amount of acceptable risk? Or in other words, what is the risk tolerance, the degree or volume of risk an organization will withstand? And third, at what point does my risk become unacceptable? What is my risk threshold? For example, it may be acceptable if a project were 5% over budget, but not be 15% over budget. Knowing these areas and amounts of risk an organization is willing to accept helps to identify the impact of risk and determine what strategies to use.